Find the area of the region between the x-axis and the graph of the function x squared plus 4x between -3 and 0. All right. These next two examples are preludes to the next section. Since we are finding the area, and this goes back to what you were saying, you can't really have a negative area. So that's where it gets a little bit tricky. We might need the use of absolute values. So we need to figure out what this graph looks like. So if you were to graph x squared plus 4x on your calculator, it would probably be fine. It would look something like this. So it wouldn't look anything like that. But basically what I'm trying to get at is that it crosses at -4 and at 0. So let me try this again. I'm not going to edit this. All right, I can do it. There's -4. I'm a winner. All right. So we are finding this area. Here's -3. We're finding this area right here. Notice that entire area is below the x-axis, which means we would have a negative value. So you can do one of two things. You can find the integral as normal and then just multiply it by -1. Or you can keep it in absolute values. It honestly does not matter. For the sake of notation, we're going to keep it in absolute values. So we're going to do the integral, the absolute value of the integral from -3 to 0 of x squared plus 4x dx. So the absolute values we keep until the end of the problem. So what is the antiderivative of x squared plus 4x? One-third x to the third. And what is the antiderivative of 4x? Be careful. Two x squared. You guys are really good talking like robots. Between -3 and 0. And again, vertical line because of the absolute value. So the only thing we've added was absolute value of r's. It's still the same type of problem. So we stick in 0, subtract, stick in -3. One thing I do not want you to get used to is that every time you stick in 0, you get 0. That is not true. It depends on the function. For most of the time, when you stick in 0 into a polynomial after you've integrated, yeah, you might get 0. However, remember, we've already done some exponents, some logs, things like that, some fractions, and they were not always going to give you 0. So before you do the absolute value part, figure out that antiderivative. You should get -9. Did everyone get -9? And then after you take the absolute value, you get +9 as your final answer. Find the area of the region between the x-axis and the graph of the function between -3 and 3. So as far as a crude graph, that's what our graph looks like. So we need to find this area here, which we just did, and let me use a different color, and this area. But since it's saying the area, anything that's below the x-axis, we have to take the absolute value of. And anything that's above, we could just take the regular integral of. Well, I picked the same exact function and the similar interval on purpose, so we don't have to double our work. So we already just found that this blue area was -9, but after the absolute value is 9. But if this was our first problem where we didn't have the previous one, your steps would be graph it to see when it crosses, because it doesn't have to cross. And wherever it crosses, that's where you break it up into parts. Okay? So we would technically have two integrals here. One for the below, one for the above. So this 9 is just going to carry for the rest of the problem. But what's the setup for the second one? The integral from what to what? 0 to 3 of x squared plus 4x. So one more time, when you're find the area of the region formulas or problems, graph it. You only care about from -3 to 3. So because it crosses again at -4, doesn't matter. Who cares? Because it's not between -3 and 3. At x equals 0, it happens to cross. To the left, it's below. To the right, it's above. We already did the area below. So now we just have to do the area above. So this should go a lot faster because we already did the antiderivative. Is 1/3 x cubed plus 2x squared. Different colors. So much fun. And now stick in your 3. I can do it. That's right. And then stick in your 0. That's right. So when you stick in 0, you get 0. How about when you stick in 3? 27? So 9 plus 27 makes, that's not going to get annoying or hard to edit out, equals 36. Hold on, we're going to do it in 3D. Ooh, pretty. I don't know how that would work in 3D, but it works in my head. It's popping out at you guys.